Welcome to our summary on falling objects and drag. So first thing we need to understand then is what we're actually talking about when we refer to weight or mass. So these are two words that you've probably used as interchangeable over the years incorrectly. So if we're talking about the weight then, what we're referring to is the force acting on an object due to gravity. Now because it's a force, it will always be measured in newtons, which has the symbol of a capital N. If we're talking about the mass of an object, however, then what we're actually referring to there is the amount of material that something is made from. So in that respect, we're looking at something that's going to be measured in kilograms. So what we actually find then is that when we're looking to see what an object's weight is actually determined by, we've got two factors there. First one is the mass of the object itself, and the second one is the gravitational field strength. Now this is something that will change depending on which planet we're on, but any of those will tell you in the question what the value for the gravitational field strength actually is. What we've got at the top there then is our calculation, and as usual we can find that on page 2 of our exam booklet. So the calculation for our weight then is the mass in kilograms times by the gravitational field strength, which is measured in newtons per kilogram. Now, as I've said, the gravitational field strength on Earth is 10 newtons per kilogram, but that's something they will tell you in the question, so you don't have to worry about remembering it. Now, when we're talking about this gravitational field strength, they may also refer to it as the acceleration due to gravity, which they sometimes give the letter G, that lowercase g. Now, what we find then is that it's going to be the same for any object at that particular point on the surface of the Earth. So no matter what your object is, as long as it's in that one point on the Earth's surface, then we will find that that acceleration due to gravity will be the same. To give you an example then of the kind of calculation you might be asked to do with the weight equals mass times gravitational field strength equation, I've got a question in the middle there for you. A large bag of rice has a mass of 2 kilograms. What is its weight? Now in the question they will also tell you that the gravitational field strength on Earth is 10 newtons per kilogram. So all we need to do there is mass times gravitational field strength. So 2 times by 10, which gives us the weight of 20 newtons. If we imagine we've got an object actually falling, so in the example I've given you here, we've got a ball that's falling onto the floor. Now as soon as we take away the surface that's holding the ball off the ground, then gravity makes that ball accelerate downwards. And as that ball actually falls, we see its speed increase. Now, what we'll also find happening at that point is that as the speed is increasing, then the size of that opposing drag force will also increase. Now, by the opposing drag force, what I'm talking about there is air resistance. As the ball falls through the air, then it's going to be hitting those particles, and that means that there will be a force acting against its motion, so acting the opposite direction to the way it's going. And as the speed increases, the size of that drag force also increases. To give you an example of the kind of diagram you might see associated with this then, we've got a leaf falling from a tree. Now what we've got on there are two different forces. We're looking at the weight and we're looking at the air resistance. So what we can see in that top part of our diagram there, as the leaf just begins to fall out of the tree, is that the weight is a much greater force than the air resistance. And the way we can tell that is by the size of the arrows. Now, as that leaf continues to fall, gravity is going to be making it accelerate, so its speed increases, and as a result of that, the air resistance also increases. And eventually what we find then is that air resistance and weight become balanced, and that then means that the speed of our leaf is constant. When we actually have an object that falls through a fluid, and by a fluid what we're talking about is either air or water, then we have drag acting on it, and that is as a result of the friction. So as it's falling through that fluid, there are particles in the fluid that are knocking into our object. So as soon as we have that, we get friction occurring, and that's going to slow down our objects. Now what we find is the faster it moves, the greater that drag force will be. If however we have no atmosphere, so this is our example on the moon for example, then we have no drag force. If there's no atmosphere, there are no particles, therefore there is no drag force. So what you can actually see are there are some great videos online where we'll drop things like a bowling ball and the feathers at exactly the same time from the same height in an area that has no atmosphere. We've artificially removed it. And what you can see in that video is that the two fall at exactly the same rate because we have no drag force slowing down those feathers as we'd normally see on Earth.